Hello dear friends, welcome to this video today. In this video guys, we shall be looking at Ohm's law guys. We shall be looking at an application of Ohm's law. So friends, Ohm's law is a very important area as far as physics is concerned because you really need to understand Ohm's law before you can study electricity in a more advanced manner, namely to study Kirchhoff's law and also some applications of electromagnetism like Lenz's law, Faraday's law, and so on guys. It's very important you understand Ohm's law. So guys, what does Ohm's law state? Ohm's law states that in a conductor, that for a conductor in an electric circuit, friends, the current passing through that conductor is directly proportional to the potential difference applied across the ends of the conductor, provided temperature and other physical conditions are held constant. I take it again, friends. The current passing through a conductor is directly proportional to the potential difference applied across the ends of that conductor, provided temperature and other physical conditions are held constant. Okay, so now guys, this is the circuit that they've given us. They want us to get the total resistance, the ammeter and the voltmeter, the ammeter and voltmeter readings, the power dissipated by the resistors, the entire resistors, and the power dissipated by the 2 ohm resistor. Okay guys, let's start from scratch. Let's start from somewhere. Now friends, to get the total resistance of this circuit, do you see that the 3 ohm and 3 ohm resistors are in parallel? Why are they in parallel, friends? They're in parallel because when current reaches at the junction, it has 2 paths in which it flows. It can either flow in this direction. The current that comes in this point can either flow here and here, right? So there are 2 paths through which current can flow. That's why this circuit is said to be what, in parallel. So friends, in such a case now, in order for us to get these components done, the switch has to be closed. Okay, so we start by saying that closing the switch, comma K, we have to start by closing the switch. Okay, so when we close the switch, guys, we see that when the switch is closed, when this guy is closed, means this circuit now is complete. So now these 2 guys are in parallel as such. For resistors in parallel, guys, we are going to have 1 over R total being the total resistance of resistors in parallel, is giving us 1 over R1 plus 1 over R2 plus dash dash dash, guys. If we have 3 resistors, it becomes 1 over R3 and so on. So in this case, guys, if you solve for this, if you evaluate this when we have just 2 of the resistors, namely this and this, taking the LCM and simplifying, we're going to have our R total being equal to what, guys? R total in parallel, let's say R total in parallel becomes what, guys? Becomes R1 times R2 over the sum of R1 and R2, which therefore means in this case, guys, our R total in parallel becomes, what is our R1, guys? Our R1 is 3, R1 is 3, R2 is still 3. So we take 3 times 3. What's 3 times 3, guys? We have 3 times 3 over what? 3 plus 3. Doing that, guys, we have our answer to what, guys? 3 times 3 is 9. 9 over 6 gives, what's 9 over 6, guys? We're going to have 3 over 2, which becomes what, guys? Perfect. We have 1.5 ohms. So guys, this is how we can get 1.5 ohm. This is how we can get the combined resistance of resistors in parallel. Now guys, do you see that the combined resistance of these 2 guys is in series with these 2 ohms? And as such, to get a combined resistance of resistors in series, we simply add their individual resistances. So in that case, to get a combined resistance, since the combined resistance of this parallel network is in series with this, we are simply going to take the combined resistance, that is R total to be equal to what, guys? 1.5 ohms plus what, guys? Plus 2 ohms. So doing that, we have what, guys? 3.5 ohms. Great. So guys, this is the R total in which we asked to find. Okay. Now, so the first part has been gotten. They want us to find, guys, the ammeter and voltmeter readings. Okay, friends, do you see that the ammeter reading is simply going to be the current that will be passing through this ammeter. It will be the current that is passing through the ammeter, right? Let's call the current I. Okay, what flows in this ammeter will be what the ammeter reads. So in such a case, guys, we have to use Ohm's law. Ohm's law, friends, in its condensed formula is saying that our V is equal to I R, where V in this case, guys, is simply the potential difference across this our circuit. I is what the current that is flowing through this circuit, and R is the combined resistance. So if we want to get the ammeter reading, means we want to get what current. So in this case, we make I the subject. It means our I becomes what, guys? I becomes